to 3 p.m. afternoon sleep. For me, the job is much more easier. We saw like a lot of code during this talk. In my talk, even though it talks about concurrency, but I have zero like Go code to show. I only have cute pictures of Go routines to show. Hopefully that sort of still excites you. So I want to talk about this problem that we've solved recently, which is building a data pipeline in Go, where we move data from MongoDB to Postgres. Right? A bit about me, real quick. I'm Chinmay. I go by this photo. Most of the folks recognize me by that photo, so I started keeping that photo so that people know, oh, this is really you. Like that. Then I go by Chinmay85 on Twitter, etc., etc. I'm founder at 1-2N, where we focus and help companies with reliability engineering, backend engineering. We work with Go, Python, Java, pretty much mainstream languages. I write stories on pragmatic engineering that we do. Some of you, I guess, follow and look at those. Personally, I like engineering in general, trade-offs, thinking about technology. I've read a lot of psychology stuff, and I'm into that as well. And percussion, I play tabla. I've trained from 4th standard to 10th standard, and then kind of left in between, but trying to get back to playing drums and tabla again. And lastly, I think this is the game. Anyone here knows? Okay, some familiar hands. This is a game that I love, Age of Empires 2. It's a pretty old game, like 25-year-old game now, but super interesting, super fun. That's my sort of favorite pastime on weekends or when I'm not playing with my daughter who's 3 years old. And so coming back, what do we want to talk about? We want to move data from MongoDB to Postgres. I'm not advocating for either Mongo or Postgres here, but just saying we had one use case where we had to migrate data from Mongo to Postgres. This is more like an ETL, like how do you go about migrating a bunch of data, right? And it's in gigabytes, not like a few MBs of data and stuff like that. So if you're not familiar with Mongo and Postgres that terminology, let me give a quick refresher. Right? So you have database, is called database in Mongo and Postgres both. There is collection in Mongo, which is called table in SQL terms, right? Then there is a document. You have a typical JSON document that you have in Mongo, a single like giant JSON doc. That's called like row, right, in the relational database. You have a field, which is a key value field that would be akin to a column in a relational database, right? And then value will be the value of the column, and rest of the other terms are very similar. Alright? So let's look at like one example of a JSON doc, right? What it would look like. So here is like a student collection, MongoDB, right? There is an ID, which is like a primary key. There is object ID usually, but I'm just keeping because this is JSON structure, so I want to write correct JSON, so that's the primary key. There is string field, numeric, boolean, various types of fields, right? And this is again string, although it looks like a date of birth, so it's a string field ultimately. Here is a nested array, right? This is how nested like JSON documents work, right? And there is a nested object also, right? So what we want to do is we want to map this to a relational schema. How do we do that, right? So let's say the simple things are pretty simple. You have a similar student collection. You have a student table in Postgres. You can map your ID, name, roll number, graduate, his graduation boolean, and then date of birth, right? These are plain simple fields that you can map as it is, as JSON fields to row columns in the relational database. What about address and phone? How do you map them? Another table, right? That's a good option, right? So then you create nested tables almost, right? Like you have a student as a parent table, and then you create a student address table, which is kind of like a foreign key kind of table where it will have its own ID as a primary key. And what you need is you need student's ID, right? That student's ID over here to be able to have as a foreign key. Although it's like a logical foreign key. There is no physical constraint in the database that you might want to add, right? And other fields are pretty similar. Same for phone. you can do primary key and right. So you essentially broken the relational like the JSON structure into a single hierarchy. You almost like flattened the JSON structure, right? If you think about it. So far with me. So we are doing data migration from this to relational. So how does it migrate, right? So your basic fields become one record in student, right? Your address, because there are two address fields in an array, they become like two entries in my address table, and my phone becomes another record in the student phone table, right? With a foreign key, logical foreign key reference, right? So on the left you see, this JSON doc. Here is an example ID, the 635 blah blah blah. That is mapped over here on the student table, one row, and there is two inserts on this side. Anyway, you see on this side there is these two inserts, and here is the student phone. Right? That's the kind of data that is mapped into your relational database. So again, coming back, we want to move data from Mongo to Postgres. Postgres uses relational structured data. We need to convert our JSON documents into a structured format, which is what we are trying to do. Okay? So this, what we just realized, what we saw is that one Mongo document, you have this one student doc in Mongo, right? That maps to almost like n SQL insert statements, right? One in the main table, two in the subtable, and one more in the other subtable, right? And there could be many such sub-nested directories, multiple sub-columns, multiple subfields and whatnot, right? So all of those have to kind of recursively be traversed to create a graph of tables almost, right? Directed acyclic graph of tables, and you map that. So you're going to have one giant Mongo document is going to convert into a nested, like a bunch of insert statements, right? And you're going to map these nested JSON and arrays into a foreign key constraint kind of tables. So far with me. So inserts are okay. Like we can imagine any insert in Mongo database. We can just convert that as it is into relational format. What will we do with updates? If already I have a student record in Mongo and somebody updates a particular value of a particular field or adds a new key value pair in that, I don't know what to do. So this may be a bit too much. There is a bunch of things that I can talk about, but I'll kind of assume that for now let's sort of pause this now. Let's assume that we solve it some way, right? We do it with alter tables or whatever. So let's not directly jump too much into the domain of that particular problem for now. Let's talk about migrating data, right? We are again coming back to migrating data from Mongo to Postgres. How do we do that, right? So when you say migration, what do we mean? Like, do you want one-time lift and shift, or do you want continuous streaming data? Right? Like I can't stop my production Mongo database and then move all the data and then randomly start using relational database. I still have to run my production Mongo, right? How do I then? So I cannot be doing single one-time migrate. At the same time, I cannot just be doing in between streaming update. I kind of need to do both. Right? I need to start with a basic first lift and shift. Have some pointers that okay, I've migrated up to this point. And from that point onwards, I'm going to copy all the incremental data, right? So this is the kind of problem that we are dealing with, let's say. So for that, we need a reliable way to track the changes to Mongo, right? Like whatever is happening inside Mongo database, either inserts or updates or deletes. We don't care about queries because they don't actually change the value of the database, right? It just inserts, updates and deletes that we are worried about. So, any thoughts on like what can we do? Like how do we get this data from Mongo? Anyone has worked with Mongo? What would be a way to get this kind of data from Mongo? Perfect, right? I don't have t-shirts to give. I have stickers to give. So, but you can get them for free. You don't have to answer questions. So, opt out. Mongo has a concept of operational log, which is itself a collection, like a Mongo collection. It's internal collection, right? It's called oplog RS collection in a local like database, which is protected by like it's only admin accessible database and whatnot. So there is permissions involved. But you can get this data, all of the changes to Mongo in that table. It's a capped collection. By cap, it means there's a fixed typical size to it, and the more records are added, the previous records will be overwritten. It's a fixed kind of circular buffer of sorts. Right? So it tracks all of your changes to Mongo. Perfect. Right? Now, how do we hook on to like? Then what's the plan? Like our plan is we hook onto this oplog and we figure out a way to convert it. But what does oplog look like here? Right? Let's look at that. So here is what insert oplog looks like. I'm omitting a bunch of other fields, so you can just concentrate on important ones. So there is this op equal to I, which says okay, it's insert oplog. There is the namespace, which talks about it's test.student, means the database name is test and the collection name is student. So it's a db.collection combination. And the O part is the actual object, the student object that actually gets inserted in the student collection. Right? Similarly for update, you have similar structure. You have op equal to u for update, you have the version, yes, and you have a bunch of other like information as to what field is updated. So for example here, I'm just showing one example where you're setting a particular field value to true. So the candidate here, we are setting her graduation to be true, right? So that if we did that in Mongo, this is what the oplog entry would look like in the Mongo oplog collection. And here again, we are assuming we are always updating by a particular ID. We are only updating one record at a time, not bulk records, and I'm simplifying stuff here, right, for our purpose. You can imagine similar delete oplog. Okay. So you might be like, okay, I thought we are kind of here for a Go talk, not Mongo and Postgres and this talk. Right? So when are we going to get to the Go part of it? So here is what let's think about this and let's talk about this now. Right? Here is the meat now. We have data in Mongo. We want to move this data to Postgres. We write a program, let's call it oplog to SQL. Okay. What we are going to do is read this oplog in a Go routine. So each gopher is a Go routine. Each horizontal yellow bar that you see is like a channel. Imagine that, right? Throughout the presentation. So you have a Go routine that connects to Mongo. It's going to read the Mongo oplog sequentially or whatever the way it gets it. It's going to push that into oplog channel. Then we need to kind of have this business logic Go routine, which is going to process and it's going to convert this big JSON doc into these SQL statements like we talked about, right? Like if you get one insert, then you're going to end up with n SQL statements. If you get an update, you may end up with a bunch of other statements, stuff like that. And then finally, imagine like we have another Go routine which just kind of sequentially executes these SQLs on Postgres. Right? So if we did that and if we hooked all of this together, ideally, theoretically, this should work. Right? So let's try this, or let's see how we go about that. Right? So we have oplog, but just inserting data in relational database doesn't really like solve the problem. Right? We have to create the schema first, right? Because unlike Mongo, relational databases require table structure to be created. So again, if we have this oplog, we are going to create a schema for test, create a table student, and we are going to migrate this data this way, right? So we need to create a table, we need to create schema, we need to then insert data into the table. So we need to create these create table queries also. So we need to kind of write a logic to parse, extract the types of columns, the field and whatnot using reflection and whatnot, and then being able to create appropriate SQL statement generator almost we have to write, and then we have to execute these SQL statements in the correct order. So it's more complex. Right? So if we did that, again, this is what it would look like. A single oplog entry would look something like this. We have the student, we have this create table test students with various values, and then we have an insert. Here I'm kind of assuming or not adding the complexity of address and phone for simplicity, right? If we have two oplogs for the same table, we have to be a bit clever, right? By that, we have to create the table and the schema only once. Because if we create the table again and if we run that SQL again, the relational database would be like, hey, this table already exists, right? So we have to kind of do a smart logic thing. Hey, if this table already exists, then don't create another create table script and whatnot, right? So there is that. But otherwise, it's just plain results. I'm not even talking about a bunch of other cases which are around adding new values, fields, deleting subfields, subfields will be modified. Let's just like assume that that's sorted for now. So again, coming back to goroutines, right, and how we can use or what did we use as a power of goroutines here, right? So recap, we have this pipeline. We ran this pipeline as it is because let's just build a sequential working solution first. Let's run it live. Let's see what happens. For about what 3.6 million oplogs, which was about 3 GB, 4 GB of data. This is all on local laptop, so there is no benchmarking as such or whatever. It's just local laptop, local Mongo, local Postgres, everything local. There is load test data generator also running locally, which is pushing these data into Mongo. There is this oplog parser running, which is moving this data into Postgres, which is being inserted. Blah, blah. The whole data pipeline running locally took like 9 hours, 20 minutes. That's pretty slow. So like, okay, what can we do? Right? Like this is clearly slow. How can we improve it? So I want to sort of ask you guys, what would we do? How would we improve it? Correct, concurrency. But where? Like, where do we add concurrency? Where do we spin up goroutines?
Process and forward.
Who's that? Okay, please say that again.
Process and convert.
Okay, process and convert oplog, right? Like this guy is clearly like doing too much work. That's going to do a lot of processing. It has to parse Mongo, oplog, it has to convert SQL, blah, blah. That's clearly the part. So, well, we do something here. We create goroutines. So let's do like a worker pool kind of pattern, right? Where we just say, hey, I'm going to read these oplogs again. They're going to get pushed into a channel, and here I'm going to spin up n number of goroutines. N can be 100, 500,000, whatever. Right? I want to configure it. Each of these goroutines are going to work on individual SQL, individual Mongo oplog document. It can be insert, update, delete, whatever it is, and it's going to like do all of this in parallel. In like assuming I have parallel like processors and whatnot, right? And then all of them are kind of funneling it into a SQL channel. Everybody kind of says, okay, I have pushed my data into SQL channel. So it's almost like a fanning pattern. Is that all we can do, or can we add more workers? Can we make it more? Can throw more goroutines at it? Okay, Postgres could be a problem. What if we like we say, okay, look, why are you alone? Like, you know, we have to read oplog because there's just one Mongo instance from which we are reading, so we can't really parallelize it. But there's multiple databases for which we are migrating. Let's say there's multiple collections, multiple databases in Mongo. So, well, on the Postgres, let's create multiple databases, multiple things. So yeah, let's add more concurrency. Let's add more goroutines everywhere. So we have goroutines on this side to process and convert to SQL, and for each SQL kind of statements, we have another set of goroutines which just bombards and adds data in Postgres. Awesome, is that done? Like, let's see. By the way, no gophers were harmed. Like you see the thing, no gophers were harmed in 606. Okay, we run this and we see, wow, that's amazing, right? Like sequential was 9 hours, 20 minutes. This is 4x improvement. Amazing, like go routines. But something fails. Like the correctness of the program is broken. And like, why? What's wrong? Like something is broken. So I want to take a pause and think what we just learned from, like we didn't cover go routines as part of the first talk as such. We covered just one last interesting exercise. What do you think could be the problem? Order of the execution, right? Like we cannot depend on order of the execution. Now, why is order of a execution problem? Right? Like see, our domain is that. Imagine again this case, right, where we have a same document in Mongo, same student collection, two documents or two Mongo oblogs, one after the other. One is the insert oblog, other is update oblog of the same inserted document, right? Like I have insert student record and I just say, oops, I made a mistake, I just need to update that field of the same student right after it, right? Imagine these two are one after another and my go routines are running like concurrently. They can pick up the result, they can convert the SQL into update statement or insert statement in concurrently, right? And they're going to write to SQL. Now the order in which they can be written to the SQL channel, I have no control over. But I actually want control because you cannot update something which is never inserted, right? So I need to, it cannot be insert and update and update and insert. It has to maintain the work order. Like I sent you work with this priority, I want the results in that priority. Like you can complete them earlier, but then keep them with you and only give me in a correct sequential order, right? Like that's what we want. So this is like a domain problem. This is clearly not a 100% parallelizable where you can just throw routines at it and then assume it to work, right? This is a kind of problem. So this is where we would get into SQL problem. So data integrity is a problem and we can't just throw worker routines, right? So far with me, right? So then, like, what do? Are we back to square one? Because we spent like almost 2 weeks building this whole thing, running it, but it failed. How do we solve it? So let's sort of apply some more brain, let's apply some more thought process to know that, hey, we have these n databases. Let's assume that we have n number of databases to migrate. And each database, let's say, has m collections. M can be variable for each of them. So we basically have to migrate n multiplied by m kind of data, right, across Mongo. Now, if we look at the previous problem, we have the problem where the database and collection has to be same, and the order in which order of oblogs for that has to be maintained. But there is not necessarily, I don't need to necessarily maintain the order of oblogs for two different databases or for two different collections, because their inserts and their updates can intermingle and have no problem, right? Like there is clearly, like they are embarrassingly parallelizing, right? But the single database and single collection, they have to be sequential, right? It's almost like if you work with Kafka, then like there's a topic and then you have to read through that topic partitions. The partition ordering is maintained, but across the topic, if the topic is distributed across multiple machines, that ordering is not maintained, right? So coming back, what we do is we say, okay, let's do a fan out. Okay. So what do? We say we have n databases. Let's pin up n number of go routines, fixed. For every new database for which there is no go routine, I'm going to spin up a go routine, right? I maintain a map. We talked about hash maps and arrays right before. So I maintain a map where incoming oblog, I check what's the database, it's test. Is the first time I'm processing oblogs for test. Hey, spin up a new go routine. You're responsible for processing test databases oblogs. Here you go. I read another oblog, it's database foo. Okay, foo, there is nothing exists. Another go routine, you handle foo. Another oplog, test, hey test, you go use that test, right? So there is n number of databases, n number of go routines. So each go routine is only responsible for that particular database processing, right? So that go routine is almost like locked. It only processes data for that database, right? Nothing else. Now, and we have n such go routines. Okay? So we're throwing worker pools in some way, but we are making it more structured, right? It's not random where just throw hundreds and thousands of them. But then, can we do something more? Again, on the SQL side, we're all again funneling it into a single funnel, right? Is there any possibility to do something more there? What if we said, okay, because we have n databases, what if we also break that part and we say, okay, for each database's SQL output, I create a separate channel. And I say throw all of that database's SQLs in that particular channel. So it's almost like a logical separation, n-end separation of sorts, right? So we have one go routine per database and one go routine for every SQL insert. So there is, if we were to count the number of go routines, we are going to have like 2 into n. Here there's going to be n here and then there's n here. Obviously there is one more go routine here or that, but we are ignoring that for now. Right? We can do one step further. What if we say, okay, we have n databases, n collections. Ultimately our goal is to have ordering for a particular collection, not necessarily for a database. Right? So what if we spin up a go routine for every database collection combination? So far, like following, I guess that this is kind of the like mind-blown moment maybe. So at this point, I had to I couldn't fit everything in a horizontal way, so I have to use a different mode to explain but it's better to explain via diagram than showing code, because then it will be like even I'll kind of lose track of where the code happens. So okay, let's walk through this. It's not that complex. This is the last part. So we have MongoDB. We read the oplogs as it is. We push them all in one oplog channel. These are oplogs for all databases, right? Because there's a single oplog collection in Mongo. This is a point where we say, okay, whatever are the oplogs coming, here is the orchestrator go routine, which is going to spin up n number of channels for each database, and for each database is going to put that particular oplog in that particular channel, right? So you have at the bottom you have these fan out go routines for n databases, right? So each go routine here is responsible for only one DB1, DB2, DB3, like that, right? So if there is n databases, there is n go routines here. Now for each go routine over there, each database may have m collections, right? So for each collection we create one channel and we push that database, that collections data in that channel. We get that. Now these go routines are just going to get db1.collection1. Like this particular go routine would always get db1.collection1's data. The next one will always get, let's say, db2.collection3's data. The next one would get db1.collection2's data, like that, right? They will never process single collections data. Like the collections data will only be processed by a single go routine, and that particular consistently hashed go routine, if I were to call it that. And then each of them funnel these into SQL statements, which are again for that particular database, that particular set of tables and collections. And again, we have these SQLs where you are now writing this database. Okay. We run this. It takes us some time to write this code, to write test cases for it. We run this, but we get great performance. This is the 5x maybe or more kind of improvement we get. So let's look at kind of more resource utilization part of how many go routines, how many databases, how many connections, what are we really doing, right? So we have a number of databases, let's for assume that 16 databases. So these are the n number of 16 go routines we are going to have. Then for each database's m collection, that's 128 let's say, we are going to have these many go routines for processing that particular database collections of logs, parsing them into SQL. And for all of them again, you have to write them into database. So you are going to have those many again. So you end up with like 2048 DB connections now. You kind of end up with a different problem. Like you have too many DB connections and you have a problem at the Postgres side now. So again, kind of like not really back to drawing board, but we're almost there. We have to apply one last improvement where instead of doing the last part over there, instead of having those many number of go routines, we again funnel them into a fixed set of go routines. I think that way we can have limited resource utilization at the database side, right? So this is what we do here. So we say, look, on the improvement, instead of doing, here is where we do improvement. Instead of having a single go routine, earlier it was like, if you see, there was a straight line all the way there. Instead of that, now you have a funnel where you have all of the collection go routines sending all of the data into a single database go routine or database channel, right? Where writes to a particular database, all of the database go to that particular channel and not per collection channel. So that's where you can kind of have a limit of, okay, if there is n database, I'm only going to open n number of DB connections, which is much more manageable, right? So we had this before, we have this after. In terms of resource optimization, we can calculate now, we have less number of go routines on the SQL processing side. So again, if you have 16, we actually only have 16 DB connections, for example, right? So this is what our sort of final concurrent data pipeline looks like, where we start from Mongo, we read the op logs, we fan out into multiple database go routines, each of them into multiple collection go routines, funnel them back into a database channel, and then write to the Postgres database. This is kind of what we ended up doing. There is so there has been some sort of learning, so I'll talk about what that has been, right? So I think it's more about understanding the domain of the problem, like what you are dealing with, instead of directly throwing fancy go routines at it, right? Obviously, building a working solution, sequential solution ideally first, to just see if it works correctly, whether you are doing things correctly. That really helps. And this is a very tricky part where you have to kind of identify what are the parts of the program that actually can be parallelized, that whether it actually makes sense to add concurrency to this program, right? And then instead of blindly applying the worker pool pattern, which is what we tried earlier, we realize that, look, this kind of doesn't work. It has to be in line with the constraint of the domain, right? You cannot just directly throw concurrency at it and expect it to work. There is a thing called Amdahl's law. If anyone knows what Amdahl's law is, okay. Do you want to talk about? Okay. So Amdahl's law, it talks about how can you, like what parts of the program can be parallelized. Imagine like there is a 20-hour program, right? But 1 hour part of the program cannot ever be parallelized. It has to be sequential. Then, no matter how many quantum computing, whatever GPUs I throw at it, I can run the 19-hour worth of program maybe within a millisecond, right? But the last 1 hour, it has to be sequential. So the total runtime of the program will always be more than 1 hour. It will be, like let's say, minuscule amount more than 1 hour, but it will always be more than 1 hour. So you kind of think about Amdahl's law, where in our case also, we couldn't just randomly throw go routines just to make things faster. We tried that using worker pools, but then it failed in terms of correctness of the program, right? So then that's where we have to consider and think about what parts of the program can actually be parallelized and only work on improving that part. And at the same time, again, Go's concurrency is super easy to use, but at the same time, it's hard to debug. And anyone has here written like concurrent code in Go that on production or use cases? Okay. Has anyone had to debug someone else's written concurrent? Like how fun was that? So I was always like fascinated of I'm going to write concurrent code. I wrote a good amount of concurrent code, and then somebody else was debugging it, like, what have you written? Like, I can't understand any of this, right? In some, and I had to do that for someone else's code, and I realized how hard sometimes it can be, right? So often, like, concurrency obviously is touted as a really good feature, and Go really gets it very like right in a lot of aspects. But still, if you don't care about performance, always like go for simple solution first, right? Like if that's something that works well, don't throw concurrency for the sake of resume-driven development of sorts, right? And finally, what we ended up with is the performant like concurrent implementation with a fan out for database. Fan out for database, but then ultimately a fan in into a single SQL channel per database, right? So that's from me. This is me. We have a Go bootcamp where we've discussed this problem in depth. We've actually done a 3.5 hours maybe live coding session of this problem statement using test-driven development. It's available on YouTube publicly. So if you're interested, please go check it out. Scan this QR code. There is a smaller version of this in a very nice story-wise format where you can start with one story, just implement the insert, then implement the update, then delete and this and that. And trust me, like this code is not that complex. Like even though it looks like such a big complex problem, the probably the number of lines of code would be less than 500, 700 lines maximum, right? So please check it out. See, happy like learning. I'm open to take any questions or any feedback. Thanks. I hope this was still like I purposely did not want to show a lot of code because then otherwise it gets too complex. Yeah. Correct. The question is how do we unit test? So for this particular case, we wrote the unit test first. In fact, like the TDD solution that we can go through, we don't have we've written unit test first, and it is unit test for the sequential implementation to start with. For the concurrent implementation, there is race condition testing that we've done, benchmark test of sorts, and there is a simple unit test in the code also, which checks for this exact case that if there is insert and update, it doesn't end up with the update and insert, the SQL error part. Right? We've added a case for that, but it's difficult to simulate that using unit test scenario because just like, very small. But we've added, we ran this using benchmark test to make sure that there is not a case like this. So, but yeah, testing concurrency and Go routines is always going to be tricky. So that's where again I keep going back to ideally doing things in a simple way if that you can do it. Other sort of advice or things that I have found useful is using existing components, like using worker groups, weight groups, right? Things like that, instead of rolling out your own patterns of sorts. There is a really good like 2 talks by I think Sanjay came out and someone Go concurrency patterns and advanced Go concurrency patterns. So there he talks about like fan in, fan out, almost like a blueprint of what code should look like for that. And those are the patterns if you follow. I think that's pretty much gets you, like I have 90% of the problem that I've had to solve were solved using just those patterns. No other, any fancy patterns that you need to invent or write special code for. hopefully, yeah, that answers. Yeah, so this was one kind of POC that we had done, and then this part of it is running in production for one of the migration part. The other is still being rolled out, and there's still some other changes that we are doing to this part.
Thank you.
So this problem, actually, if you this problem statement is already, there is a repo for it called Stampede. It's in Java. It's a big MongoDB migration tool. We've built like a Go version of it in a minuscule way for our use case, which we were dealing with. So the problem statement of all the stories and all that is open source. Even the code, what you can see for the concurrent implementation that I saw, that is also available. There is Docker compose file, etc. So you can run these benchmarks or whatever locally, and just spin up Docker compose, run the entire stack, see the pipeline, play with it. You can add number of database and whatnot. I have also written data simulator for this, where you can create bunch of data in MongoDB and then load test the system that way, just to play with the concurrency parts of
in terms of reconciling in production, would you advise at a row level checking, say for example, printing on the entire database, or a row level? What works for you? Say for example, in the case of the financial transactions, what advice would you give? Because as when you bring in concurrency, there is a chance that the records might go up. There might be discrepancies.
Yeah, I think so. Unfortunately, I can talk more about our production use case because of the other parts. But what I would do, in that case, is one, instead of building a tool ourselves, I would probably see if something off the shelf can be used. Because again, building something like this, there is a lot of domain that we had to add for SQL parsing. Like we had to generate SQL, we had to look at appropriate data types and nested tables and columns, and what if two tables have the same, two collections have the same name, we don't want to end up with the same duplicate tables in database and whatnot. So there's a lot of corner edge cases that we had to handle. Thankfully for the kind of data that we had, the solution that we built was okay, worked very well. But for a generic end-to-end use case, I would probably go with some either off-the-shelf tool or something like that.
Thank you.
So hi Chinmay, you explained the real world problems, how we can solve that disparate data migration using this concurrency. But the question is here, I'm from the Java, so we have already Java threads. So how is can added advantage we have we go with Go concurrency basically, because we can go directly with the Go multiple threads like that. So what's the added advantage?
So your question is, how do Go threads or Go routines compare with Java threads?
Java,
Sorry, they should just mute that. Yes, I think overall I would say both languages are pretty mature. JVM has been around since 20-25 years now. So I have written good amount of concurrent programs in JVM also long back. It really kind of depends on use case. For what I have realized though is there is bunch of existing open source data tools written in Java, like Kafka, Flink, Spark, Java, Scala, the whole JVM stack, right? So if you're playing with those tools, then going with a JVM kind of language makes it easier. having said that, data pipelines are also built and run very well in Go these days. So depends on what you are really trying to do. Overall, just comparing I think two languages, maybe Gautam had a talk where he had you had language roast kind of talk, right? Where you would look at each language and its features and say, okay, what's good and bad, agree about those languages. Probably that's something that we can get into. Not sure if that straight away answers the question, but more like depends on the use case. So use the set of community related tools which are already built for that use case. Like if you're using other JVM like Spark, etc., then makes sense to go with that. If not, then go. Even Python has a bunch of support for that.
Pass down to existing concurrency pattern.
So I think there is the question is, do all problems fall into existing concurrency patterns?
Yeah.
Most of them that I have had to deal with in my experience have been very standard. Like there has been standard concurrency patterns. So which is where I'll refer to the two YouTube lectures on the talks by Sanjay Gemath, right? There's advanced Go concurrency patterns and Go concurrency patterns. Like if you look at those two talks, those topics like where there's either fan in, fan out, where there's a producer consumer pattern, where there is one producer, multiple consumers, multiple producers, one consumers, all of that mesh kind of structure, data pipeline structure that they create, that's pretty much what you mostly end up in the real world. I'm guessing for very specialized like graph database or like other type of specialized queries, there might be some more nuanced patterns, but for typical data pipelines, it has been mostly one to n, n to one join, one to one consumer. Those kind of the patterns have been mostly the case. So those can be solved by using your weight groups or just count down latches and logs and stuff like that.
Are there any ETL tools based on Go? Like for Apache Airflow is based on Python. So like that, do we have?
Yeah. So we haven't. I don't know of any that we have used in production. Like, I have not used any in production as such. That's something. Has anyone used like any data pipeline like ETL tools in Go? Alright, yeah, if there's no question, then yeah, I'll hang around, no problem. Sure. Okay.
So I think you mentioned about the MongoDB. Are they specific to Mongo and Postgres, or that can be sort of?
Yeah, so the question is, this
can you make
data
it Mongo?
migration, is this specific to Mongo and Postgres only, or can it be anything? So it is specific to Mongo for sure, because we are reading the log and there is a specific structure. But because we are outputting SQL, we could output it to any relational database. So MySQL, Oracle, anything would work that way. Because it's as long as it's a SQL 99 or whatever the latest SQL standard that all databases support, that can be compatible. I had a thought, like I think Rushi also mentioned about migrating from key value to Mongo or Mongo to key value or those kind of use case. I haven't had to face them yet, but the key value we've had to do somewhat, especially we were migrating data from console, which is a key value store, to a different key value store. But then in that case, we could just take a backup of console, write a batch program, go over whatever, and then insert those keys directly. It wasn't that fast updated real-time update data store. It was more config store, so we could just take a backup of all of that once and upload it another time and then just point it to that. So that way, that hasn't been the case, at least on production. But yeah, interesting to think about.
Hi. we cannot fire like indefinite number of routines first.
Can you hold the mic?
Okay. So we cannot fire indefinite number of routines as our wish, right? Source constraint. So like even though if I fire millions of routines, so CPU cannot accommodate all the routines at once. So let's say we have 8 core. So let's say 8 processes are running in parallel. So all the other routines will be queued up, right? So I want to understand, like, is there anything like batch things you have implemented to reduce the number of routines, and is there any mathematical model you have ran to get the optimized number of routines?
Okay, so I'll just try to reframe the question.
One more thing, like it should be like considering the resource constraint, like how you came up with that number of routines.
Yeah. So I think the question is how did we decide to use the number of routines that we ended up deciding, right? I think initially obviously the worker pool was like, okay, we just started with 1,000 or whatever and just see, but then worker pool really failed completely in terms of correctness of the problem solution. So that was just completely ruled out. For the database and collection part, we realized ultimately for a particular collection I have to process records sequentially. So I'm limited by the number of unique collections I have in the database. So that's why that was again capped at n number of databases multiplied by m collections. On the database Postgres side, we actually, like, you saw the slide where there was 2,000 or more connections to database, right? And that was clearly causing problems. So we got an error on the database saying, okay, too many open connections or can't open connection to database, and there was a CPU spike and memory spike and whatnot. And that's where we realized, okay, we are actually opening too many DB connections. Can we reduce it? And what would be a good optimal number? So because we are writing to one database, maybe just use one connection for that database and write all the records, maybe even in a batch, like batch SQL transaction. So that way we ended up with, again, using the domain knowledge that we had was useful.
Right. Writing into database in a batch, it's okay. So I have one more question, like from the Mongo you are reading these logs, is it happening one after other, or else are you reading, like are you spinning up routines for reading the log, because every log is independent to each other. Inside a log, the operations which was performed on the particular log has to be ordered, but one log and a second log will be completely independent. You can process both of them in parallel. So is it something like you are taking 5 logs at once and processing them once, so that it will reduce 5 routines, like in the first step?
6, 8, 14.
Like, I just want to know.
Yeah,
like,
so I think if I understand the question, the pipeline runs almost in a, think of one unit of computation as one Mongo block. So you get one Mongo block. As soon as you read that, it will be pushed to the channel. It will be read by the available Go routine. And when the synchronization happens, the Go routine will read the value. This Go routine will be free to read another uplog and to push that another uplog to another Go routine. Right? Because Go routines, the whole channel mechanism is a synchronization mechanism. Like if both of us are there to do a handshake, that's when we actually exchange the data, right? Otherwise, it's blocking, like in the sense that, okay, I am waiting for somebody to read this value, but there's no Go routine to read the value. I'm standing in, I can't do my work. Right? So in that way, the channel mechanism helps to synchronize, and then if you have, you can kind of control the throughput or concurrency by adding, like if you add the number of routines here, then all the left side has to do is read the data and just push it to the next available worker. So it's almost like a task distribution, which doesn't take much time. So in that way, this is how each record will just run effectively. Like then, if there is n number of Go routines available on the right side, there will be n concurrent processing or parallel processing will happen for n records at a time.
Like this is not guaranteed, like n concurrent will happen, because again, same, because I faced this issue where I was working recently. So yeah, I think here the number of records are like 3.5 million.
Yeah, 3.6 million records.
Okay, so might be number of cores which you used might be a little higher number. So
Correct. So ultimately, it will be dependent on the hardware capability. Like you cannot go more than, if you go by more than the max procs, then anyway there's going to be contention blocking. So you would want to have it maximum to the go max procs, which is the number of CPUs you have, and the threading etc. included. That way, each go routine actually kind of gets its own nice area without any contention. It can kind of work. So it depends on hardware. Like this is not purely software concern. So that way.
thank you. I just want to know one, like, is there any mathematical model your company has so that that will be helpful for me. Like,
I don't think, I mean, we have not done any mathematical model. That's something interesting.
So in general, from the like when you want to take full resource from the resource utilization perspective of the hardware, not specific to the domain problem that we are discussing now. In general, what metrics you see to understand whether we are taking full utilization of the hardware or there is how you identify the scope for parallelism, CPU utilization, or like what metrics you see so that you know.
Correct. So the question is, what metrics do we see for ensuring hardware utilization to the optimal level? So basically, CPU is one, and in some way, I think it still depends on the type of problem. Like if your problem is more CPU bound, then it makes sense to look at CPU. But if the problem is more I/O, then the CPU will always be 3, 5, 10%, no matter what you do. Right? But there will be disk IOPS that you might want to look at. Or your IO stat is one command in Linux which will give you how many IOPS are happening, is that being throttled, what's the page swapping on the OS like, whether you have that enabled or not. So depending on the really the type of workload you have, you have to either go CPU bound, like where CPU becomes the bottleneck and you need to throw more processing power, or in other cases you have to throw better network, better hardware in terms of disks, and even like RAM. Like adding just more RAM will make things much more easier because you don't have to read data off the disk that much. So there is a other recent talk that I'm working on, which is about the whole, the two types of workload essentially, like whether you are running the IO bound workload or CPU, and based on that you have to pick and choose the right set of metrics even to look at. Yeah, hopefully that answers. Oftentimes, like for this case, what I realize is moving compute to where the data is, that is also useful sometimes. Like instead of moving data from your buckets or whatever, right, to your server and then doing some processing on the server, etc. You can, if you can run functions on the edge to compute there itself. Like those are some other wins that you could do. I mean, if you are into that super performance kind of that kind of stuff. So instead of moving data to compute, because moving data means network IOPS, and then if the data is encrypted at rest, then you are decrypting, moving a lot of components around, you're rewriting the data again.
Serialization basically.
Yeah, it's just too much of serialization, deserialization. Instead of that, if you can just move the compute closer to where the data is, just run the compute and then move the final computed data around, that's another pattern that you can track.
So since we have taken an ETL example here, like the one you demonstrated, so basically migration from Mongo to Postgre. So talking at ETL level perspective of things, it can be from one application to another, irrespective of the application that we are using. So whatever we took, like the table customization part, usually like you have a table, and if you have another level of data, you can add it as an inner table to it, and using ID as the foreign key for it. So the thing here is that my basic question would be that all these things can be done with Java, and same with the concurrency level of aspect. Java is already implemented. Even for hash maps, we have concurrent hash map. So this would be a simpler implementation of things. So is there any ETL, I would say, ETL perspective or an ETL advantage of using Go specifically? Since we have taken an ETL user case, and actually I've worked on ETL background, so I had this query.
Yeah. I think, so in our case, the rest of the stack of the whole company was also Go, which is where we were looking for similar stack, similar solution that everybody is familiar and comfortable with. That was, I think, primarily one of the reasons to choose Go. That is mainly the real world answer. It's not that any problem in my mind can be solved by any language or most languages. Let's say any general purpose language can solve any general purpose problem. Then what are we really using? If you're using a particular language and the entire ecosystem, tools, systems, debugging, monitoring, all of it is built for that in the community, in the company, for example, then it makes sense to kind of go with that language. So that was the reason and rationale we went, more than anything that XYZ is better or ABC language is better. Hopefully that makes sense.
Yeah, thanks.
Awesome. This is amazing. Like, great response. Thank you so much, guys. I really appreciate it. Yeah, we're spending Saturday evening like thinking and talking about Go. Amazing.
Hello. Thank you, Mr. Chinmay, for sharing your expertise with us today. The way you have taken us through comprehensive topics in Golang with ease has left us with much to ponder. I would like to invite Mr. Rishikesh to honor our guest with a token of thank you. Okay, so you all have been a wonderful audience today, and now we are going to jump into the next sessions where you all can interact a bit more. So now it's time for a flash talk session where the audience is going to take the stage. Nobody reached out to us so far, we don't have nominees, but does anyone wants to share any experience they've had or any interesting problem they have solved with Golang and how they came across it? Anyone? We have time. Does anyone wants to speak?
So, guys, this is flash talk. How many of you actually want to speak at a conference later on, sometime? Aspirational level, right? This is the chance that we get to come here and see what it's like to stand in front of the stage and have so many eyes looking at you and get your 5 minutes, 2 minutes, 3 minutes in the limelight. It helps. So please try it. It really helps.
Hello, are you able to hear me? So we use Golang in our production system. I work for retail self-checkout system. So we have this use case. Basically, sometimes our application depends on catchy and message queue. Sometimes message queue and catchy, which is Redis, and message queue is MQTT. Sometimes they get disconnected somehow. But we want to make sure our application continue. Like we want to implement fault tolerant kind of a mechanism. So what we did is like while application bootstrapping, So we basically used Go timer.ticker. So every 10 seconds, let's say our application got disconnected from cache and message queue, but we use an in-memory map or an object. So let's say while request processing they disconnected, we store that in the in-memory, and the time.ticker we run one Go routine. Basically it checks if there is any data present in that message queue or not. I mean in that map or not. If the length is if there are any objects in that particular map and cache comes back or message queue comes back, we try to insert it. So basically we use time.ticker around 10, like it can be configurable 10 seconds. So we spin up that Go routine while application bootstrapping. That is something I achieved. Yeah. And one more thing I just want to share, like throughout my experience, I realized that whatever the language, framework, process we follow, it's all about the software design, like how you want to design that particular struct, how you want to make that interface. I think it would be same for all programming languages. Like let's say we want to build an e-commerce application. So we might divide it into microservices, and let's say we take a Golang or Java. So we just want to do that software design, how to design that particular class, how to design that particular interface. So I realized that design patterns is more important even in any programming languages. That is something I want to share. I'm learning around it. My name is Ramu. I have around 5+ years of experience in software. I've been using Go from last 3.5 years. So I'm interested in Kubernetes and Docker, this CNCF ecosystem, and also observability, O level. Thank you.
Hello. Yes, whatever I understand, like you are doing health check, right? You see your application where it's connected to TDD or not, right? It's like caches. So you can do this health checkup with Kubernetes also, right? Kubernetes. Hello?
Yeah, because the liveness readiness.
Yes, so we can do this health check from the Kubernetes also, right? So why you are going to, why you are checking health from the application?
While inserting into the application, like let's say I received a request and I'm doing some processing on the particular object. So try to insert, like I try to insert into the cache and it's failed. That means cache might crash or it failed. I don't know. I'm not doing Kubernetes native probe checking in the application. I'm in the application code. So
okay.
If I am unable to insert into the cache, that means cache might crash or something happened. So that's why I'm maintaining the in-memory map object.
Okay.
And once I insert into it, my Go routine, which I use in time.ticker, so it processes it. It processes only if cache is available. It runs in another Go routine.
Okay.
Basically that I want.
I'm Tej. I work at CrowdStrike. I have around 10 years of experience. I have interest in distributed systems. Recently, I started learning Go. Anything related to programming, reliability, these are my interested topics. So I want to talk about the reliability in distributed systems. So in my work that I do, the problem that we are solving is we have to interact with a lot of vendor APIs. We have to get data from multiple sources those are which are not in our control. So we are not maintaining those endpoints. So what used to happen in general, like for example, the vendor is down, or like you have to get data, right? If you have to get data from a source, you have to have right credentials. You have to validate the entire thing. Only then data comes. And sometimes vendor changes the contract and then it breaks. So we used to get a lot of incidents, late night pager duty alerts. Things used to be very chaotic. So many of you might be aware of this pattern. Like Gautam also said, it applies to life. You have to fail fast sometimes so that you don't waste resources, and then also you don't cause problems later when one problem is leading to other problem, and it ultimately leads to entire system going down, cascading failures. So what we did, Go has open source circuit breaker called Ghost. It implemented by Sony. It's available in GitHub, Go Breaker. So what we did, so how many of you know about circuit breaker? So I assume some of you know it, but for everyone who is not aware, circuit breaker is like, I think in everybody's home, we have electrical circuit breaker. So if the load is very high, instead of having the effect on the entire appliances, the component in our home detects the load and then it short circuits so that rest of the system is guarded from the overall failure. So we did the same thing. So whenever we receive, so same in software also, the circuit breaker concept. So we have circuit breaker has multiple stages. So we make a request to the vendor and then we observe the success and failure scenarios. So when it is basically a configuration, you can see, okay, there are multiple variations of circuit breaker. Some of them are time based, some are general circuit breakers. So in our case, we went with a normal general circuit breaker. So you see the failures. If it is crossing certain number of failures, then you don't make actually call to the vendor. You just fail fast in your local component itself. So that that leads to a lot of failures in the system, and then metrics will go up, and then you get an alert. When you see, let's say you are making in a day 100 calls, and let's say the credentials are expired. So no matter how many times you retry, you're going to get a failure, right? So instead of that, you can keep a configuration. If I get these kind of failures, for these many number of failures, for this error code, I just fail locally, fail fast, and then you can have a configuration, like it has a concept of open and closed. So when the circuit is open, basically you are failing fast. When your circuit is closed, you make actual connection. So there is another possibility. You have to tune the parameters properly. If you keep the circuit open always, then you're not actually making call to the vendor, right? You're just failing fast. So at some point you have to close it and then make connection. So you have to play with the parameters so that you choose a trade-off between availability of your system and then guarding from failures. So I hope this helps. Any questions?
Yeah, so while you're using the concurrency pattern, if you're checking for the failures within your system which you handle, how do you notify the different coroutines that there is some problem with the particular process, and you could preemptively stop the batch processing, or how do you handle the failure at a particular time, at a point of time?
This is not specific to concurrency system, right? Like you keep a map basically that has this counters, and then depending on the failure percentage, you can determine how the system should function.
So let's say like if we have different routines, different go routines are running the process, and you need to like notify them as well. Like, is there any practical scenario that has happened in this?
So pattern in the sense, so this is like another layer in your system. So let's say the input. So there is one layer which is doing this concurrency thing, and then there is another layer which is talking to different outside the system. So circuit breaker is a layer in between. Maybe we can go for advanced, concurrency supported version. But what we have, I can talk my experience. We are going with a basic version which is not advanced, right? Like we are going with a simple map, and it is able to help us.
Select on an exit channel, the usual. Select on an exit, listen on an exit channel, select and wait for it. If somebody wants to prevent it, it's going to just send a message on that channel and figure it out. Or you want to bring basically open cell.
Okay, any other questions?
Memory, CPU plus. This circuit breaker has to run all the time, right?
I mean, it depends, right? Like for us, the unit of circuit is the connection ID. Like if you want more, like if that particular unit is not fitting in the memory, you can have it, keep it in the Redis also. So then it will be more scalable. It can handle large amount of connections or units.
Thank you. Yeah. So if you're stopping at a point, and how can you get to know like when to start back, when to resume the same process?
Yeah, so basically we have counters, right? So, and we have a timer attached to the counters. So in our case, we keep the counter as, it is a configuration, we kept 15 minutes. So after 15 minutes, the counters will reset. And then again we'll monitor the success and failures. Within the 15 minutes, if we see the number of failures cross the threshold, we'll again open. After 15 minutes, again it will be closed. So that we have to tune depending on the domain, the problem we are trying to solve. Thanks. Okay, thank you. I also want to thank NPCI for conducting this. This is very helpful and good opportunity.
Thank you to our future speakers. Now let us promptly jump into the quiz. So are you all excited? No, this is not the excitement. Come on, a bit louder. See, the prize is going to be very delicious and can be shared among each other as well. Okay, so make sure you clap for the winners so that they end up sharing the prize with you, okay? So I'll tell you the format of the quiz. A question will appear one by one on the screen. The answers will follow right after. And whoever answers the correct answer and is first to answer that will receive the prize. This is almost like fastest finger first. So let us jump in. These riddles are a bit of tongue twisters, so forgive me if I make mistakes, okay? Okay, so I'll read out the question and then please raise your hand to answer. Our team is right here. They will hand you the mic and start with your name and what you do, and then please answer. I help you synchronize with me. Acquiring logs and much more, guarding shared resources galore. What am I? No. So you can't answer like this. Then there is no winner. Who raised hand first? No, you can't be like this.
Hello, Rakesh sir.
Okay, clap for him, please. Okay, we'll move on to the next. I hope it doesn't happen. Okay. So the next question is in Golang. I'm error prone, handling failures on my own. Nil or not, I'll help you know when things go right or take a blow. What am I? Okay.
Error.
Yes. See, he's got 2 chocolates, okay? Make sure you take some from him. Okay, next question. I'm a keyword in Go. I will be used to go. Somewhere in Go. Who am I? No.
Go to.
Not correct. It's right, it's correct, it's go to.
Hi all, I am Arnav. I work in this.
So, next question. I'm like a set but only contain keys. No duplicates allowed, that's one of my techniques. With constant time operations, I'm quite a perk. Used in hash-based algorithms, I make your life work. What am I?
Map.
Correct.
Kumar.
Okay, thank you. Okay, next question. I'm a way to check before code execution, making sure everything's in the right resolution. What am I? Preventing panic scare in Go with my cautious care.
Hello, I am Ayush Kumar working in NPCI. So the answer is panic.
No. Wait. Give the mic to him. He's raised the hand a lot.
Recover. The answer is recover.
Okay, yes, sir. See, there are only 10 questions and we are going to the 6th one, so please answer. Yeah, can a few of you come in the front also? There are a few people raising hands in the front. Okay, ready? I am a small unit, a piece of a whole. In Go, I hold data and control. With fields and methods, I define my role. What am I in the world of Go? Correct. Please clap a bit louder. Okay, next question. I am a statement that might seem benign, yet I'm crucial for atomic design. What am I, this key player in Go where concurrency is data?
Atomic.
What is the answer?
Atomic.
Yes, correct. Finally, we got to answer. I'm a way to handle errors gracefully and clear. In Go, I am a mechanism to persevere. What am I? Ensuring smooth Go programming cheer. The one with the mask. Please share your name.
Sai Chiran from NPCA.
Yes, correct, Differ. second last one, so gear up if you need another surprise. Okay. I am a built-in function, but not for slicing or mapping. I don't modify the original, just inspecting. What am I called? This detective stance in no a puzzling circumstance. Yes, correct. Okay, last one. In a collection type, like an array, in row I'm flexible, I don't break. You can append and row it day by day, elements of the same type, I can make list. Amazing. Another round of applause for everybody. Alright, great. You all have been a great audience. And we are now at our last session that is going to be networking for the evening. And I would like to take this moment to thank our guest speakers for adding incredible value and encouraging our audience so much throughout this event, and our organizing committee for making this event a success. And lastly, our audience for being such a great sport. Thank you. Now, we have some snacks for you and some goodies. So you can go ahead and grab some goodies for yourself. And to go there, you're going to use the gates in the back, the doors in the back, and there will be a table set up for snacks. So please go ahead, grab some for yourself, have fun, get to know each other. Thank you. We have to take a photo before you all go, because after that we won't be able to get a photo. Everybody please wait. Everybody please wait, we'll take a photo first. Please come by the stage.
Seven 15. Hi, how do you do it?
पहले हमारे पनिया पिघल जाएगी हमारा बहुत क्या स्ट्रगल हो recording